All right, let's keep moving through cleaning our data. In this lesson, we're going to remove outliers in our data. Again, this is to make sure our model is fitting the actual trends in our data and not chasing down the outliers. Now, typically, this is called capping to remove the outliers at the high end and flooring to remove the outliers at the low end. But in this case, we're going to just be capping our features because none of our features could have outliers at the low end. Let's start by reading our data that we saved from the previous lesson, and let's go ahead and describe on that. Now, it's worth noting that we're only looking for outliers in a one-dimensional space in this exercise. In other words, we know that fare and passenger class are correlated. As the passenger class goes down, fare goes up. So in this exercise, we could see that a passenger that had a fare of 50, and that would be high, but not high enough to be considered an outlier based on the distribution of the fare. However, if the fare of 50 was for third-class passengers, that would likely be an outlier in a two-dimensional space, as we would expect the third-class passengers to be on the low range of the distribution of fare. So that's an example of a data point that would be considered an outlier in a two-dimensional space, but it would not be in a one-dimensional space. And again, we're going to be focusing on just outliers in a one-dimensional space. We can see that the max values for fare and age might be a little extreme, but the rest seem okay. But that's not really a thorough analysis. Let's get a little more concrete with this. So we know that passenger class cannot exceed 3, so we're simply going to ignore that feature for now. Let's go ahead and look at age, siblings and spouses, parents and children, and fare. For each of these, we're going to take a full distribution of values. And then we're going to set the thresholds to identify outliers that exceed those given thresholds. The thresholds we're going to set are going to start at the 95th percentile, 99th percentile, and 3 standard deviations above the mean is commonly used as a threshold to identify outliers. Now let's go ahead and define a function that's going to do that for us. Next, we're going to pass in the feature. We're going to extract the values from that data frame, and then we're going to calculate the mean and the standard deviation. Then we're going to look through each value for that feature. We'll calculate the z-score, which is the number of standard deviations above the mean. Then we're going to check to see if it's more than 3 standard deviations above the mean. And if it is, then we're going to assign it to a list of outliers. Then we're going to print out the results. So let's go ahead and execute the function. Then we're going to loop through the 4 features that we're interested in and pass each of those features into our detect outlier function. Now you can experiment with testing different thresholds. There's not necessarily a wrong or a right answer here. Now just looking at the results at a high level here, since there's not too many really extreme outliers, I'm just going to go with the 99th percentile to cap out the top 5 or 10 most extreme values. With that said, from what we saw in the describe, we can see that the max for siblings and spouses and parents and children are 8 and 6, which is reasonable. So there's probably no good reason to cap them out at 4 or 5. So let's just leave those alone, and we'll cap out age and fare. So again, what we're going to be doing on this age clean column, and we'll just call this nice clip method, which will just cap that feature. And then we're going to tell it what we want to set the upper boundary equal to on the age clean feature. And then we're going to grab that quantile in the 99th percent, and then we're going to tell it to do in place. Basically what we're saying is, let's set an upper boundary equal to whatever the 99th percentile of this feature is. And then we're going to do that in place. And that means don't create a new data frame or a feature. And then we're going to do the same thing to fare, so that we can copy this all down here, and we're just going to replace age clean with fare. Now the difference here is because the fare is a raw feature unlike age clean, we do not actually want to create a new feature here. So let's copy it here, and we're going to set this whole thing equal to fare clean. So let's go ahead and run that, and then describe on our data again, just to make sure that it did what we expected. So now we can peruse the uncleaned age feature and compare it to the age clean feature, and we can clearly see it's been capped. The next thing we want to do is look at the unclean fare features and compare it to the cap version, and you can see that our capping did what we expected. Lastly, we're going to write out our data to our data set called Titanic Cap, and don't forget the index false argument. In the next lesson, we're going to pick up on this data set, and we're going to work on transforming the skewed features.